Okay, Algebra, I hope you had a good Thanksgiving weekend. Today we're going to try best fit lines. So the last time you were with me or watched a video, we talked about scatter plots. So we're going to continue on with best fit lines, and I said Mr. White sometimes calls this a trend line. So best fit lines, one thing I want you to realize, it's an approximation. They're approximating the line of best fit of a bunch of points or scatter plots. So it says the line of best fit, they're drawn in a scatter plot to help show the correlation that we learned last week between two sets of data. This is used when the slope is not constant, so you can't draw a straight line through all the dots. They are also used to make predictions. So later in the week, we will talk about how to make a prediction. When you create a line of best fit or right one, here are the steps. But before we go over the steps, let's look over here. It says age of car in years, resale value in thousands. So even this is like a 2, that's a 2,000 reading. So, number 1 says, steps for writing a line or best fit line equation. First, choose 2 points that appear best approximating the data and draw a line through them. Well, this one has a line already drawn through it for you. So we are going to look at the line drawn and pick 2 points that represent that line. Now, if you look down here, this point is actually on the line of best fit. We want to pick a second point that is closest to the line of best fit, which would be this one here. So one of our ordered pairs would be 2, 10, and this time I'm going to make it 10,000 because it says it's in thousands. And the second one I'm going to use is 8, 2,000. Now notice it says there's a negative trend here because when you buy a car, the value of it decreases. Now we know there's antique cars that are worth a lot, but on average, the car decreases in value. After we do that, we're going to find the slope between the 2 points, which I'll show you here in a minute, so you have to do some manual work. You're going to find the y-intercept using the points, so you're probably going to have to use point slope form. We just learned the past month. And you're going to write an equation in y equals mx plus b form. So let me pull this down here some. We have our 2 points. This is the graph above shows the resale value of a car after being owned for a number of years. Write an equation of the line of best fit. So we have our 2 points. I'm going to write them down again. We have 2, 10,000. And we have 8, 2,000. Oops. We're going to find the slope using the slope formula. So 10,000 minus 2,000, 2 minus 8, it gives me 8,000 over negative 6. Now you're going to divide this. You're not going to simplify it because this is an approximation. So you want to divide this and make it a number for your slope. When you take 8,000 divided by negative 6, you get negative $1,333.3 repeating. So I'm going to round it to the nearest 10. If you want to go to the hundreds, you can do that. I'm only going to the nearest 10. Then I have to use my slope and a point. So let's see, I'll pick 8, 2,000. You can use the other one if you want. It doesn't really matter. So this will be y minus 2,000 equals negative 1,333.3 times x minus 8. We're going to distribute on the right. Y minus 2,000, negative 1,333.3 x plus 10,000 666.6 repeating, so I'm going to round that to 7. Remember, this is an approximation. I'm going to add 2 thousands to both sides. And I get y equals negative 1,333.3x plus 12,666.7. Now, sometimes you will see these equal signs as squigglies. 2 squigglies mean approximate. So you might see either way, equals or approximately. And that represents our equation. Now this is talking about the age of a car and the resale value. So this is where you have to use your interpreting skills that we haven't used for a while. It says, what does the slope mean? The slope is negative. Negative $1,333.30. So I want a sentence. So I would say, the car is losing value. You want to say losing because it's negative. The car is losing value at a rate of $1,333.3 per year. We've interpreted slope before, so I hope you remember that. It says, what does the y-intercept mean? Y-intercept is at 12,666.7. So I would say original price of the car was, and I'm going to add a word here, approximately. Because this is an approximation. $12,666.70. And then it asks you for an x-intercept. So to find an x-intercept, remember, if we look at the graph, there's a line there. We can take a guess at what that is, or you can actually find it. We can use our equation. An x-intercept is when y is 0. So we say 0 equals negative 1333.3x plus $12,666.07. I'm going to add $1,333.03 x to both sides. And then I'm going to divide both sides by $1,333.30. When you divide, you get x is approximately 9.5. So the x-intercept is 9.50, which means after approximately 9.5 years, the car is worth $0. Alright? Let's try one more, and then you can try some on your own. The graph below shows the amount of revenue in thousands, so this is in thousands again, for each year at a car dealership. This time it asks you to draw a line of best fit and write an equation. Now hopefully you have something you can use as a straight edge. It's hard for me to draw on the board, but I'll try my best. When you draw a line of best fit, it should go through the middle of the data. So you want to draw a line that goes through the middle of the data the best you can with a ruler or straight edge if you have it. having the same amount of points above and below. So I'm going to draw a few lines. This is not the middle of the data. Get rid of that. If it works. Come on. Okay. If you draw it like this, that is not through the middle of the data. That's above it. If you draw like this, that's not through the middle of the data. It's below it. So you want to try to draw it through the middle of the data. I don't like that one. Once again. I don't have a straight edge. Let's try it one more time. Do I have any lines up there? No. Let me try it one more time. That seems the best I can without a rule. So, once you draw a line, hopefully you have a straight edge, I'm going to pick this point and this point. Okay? You pick points that are closest to your line. In this example, we encounter a problem throw. If you notice, this says year down here. So put a little note. You can't use dates or years to make a line of best fit. So when this happens, you have to create kind of like a new x values. So at the corner here, it says 0. So we're going to note that x equals 0 is our starting year. And that's going to be the year 1998. So this graph is starting in 1998. And then we kind of rethink these as 1, 2, 3, 4, 5, 6, 7, 8, 9. These are 10 years from the year 1998. So when you pick your points, I'm going to pick the ordered pair right here, 6. And this time, I'm going to do it just as the number 6, even though it says 6,000. You can do it that way. And the second one is the ordered pair 9, 8. So this is 9 years since 1998, and that is 8,000. So, you got to find the slope. M equals 6 minus 8, 6 minus 9. It gives me negative 2 over negative 3, but remember I want you to divide this. When you divide it, you get 0.6 repeating. I'm going to go 2 decimal places this time. You can go 1 decimal point, you can go 2 decimal points. These are approximations. I'm going to take this slope and the ordered pair 6, 6. Y minus 6 equals 0.67 times x minus 6. Y minus 6 equals 0.67x minus 4.02. Add 6, add 6. I'm going to write my equation. Where am I going to write? Right in here. Y equals 0.67x plus 2.02. Now, remember, this is an approximation. It says, what does the slope mean? So, it's positive, so this time it's increasing or going up. And this is talking about revenue per year. So I'm going to say the revenue increases by 0.67. Now that represents thousands. So I'm going to write the word thousands per year. Is the slope is thousands per year. And then it says the y-intercept. So this is where you have to recall you made this starting year 1998. So you're going to use 1998. The y-intercept means in 1998, the car dealer revenue dealership revenue was $2.02 thousand. And those are two different examples of best fit line. Now I believe there's a few for you to try. If you have a question, email me, let me know.